All right, here we go. 5.4b, sum and difference formulas. So hopefully you have your reference sheets out because we're going to use them a lot. All right, let's do this. So this first one we have is cosine of arctangent of 1 plus arc cosine of x. And we're going to write that using an algebraic expression. All right. So we're going to use those sum and difference formulas from the other day. Which one am I going to use? Am I going to use 1, 2, 3, or 4? Which one does it look like? 3. We're going to use the third one. All right, and I'm going to call this one u, and I'm going to call this one v. So I'm going to go ahead and just rewrite this formula. So now I'm going to have cosine of u, and then cosine of v, and then minus sine of u, sine of v. Now, when we dealt with these arctangents of 1 and arc cosine of 1 and arc sines of blah, 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 what did I have you read an arc as? At what angle is. All right? And so the way that I want you to read this is like, at what angle is tangent 1? And that's going to help us draw our little triangle. So that's what we're going to do. We're going to draw our little triangle, and I'm going to make this my u triangle. So this means that, like, what angle is tangent 1? Well, what the heck is tangent? Y over x, or opposite over adjacent, right? So my opposite, or my y, is 1. And then what's my adjacent? 1. How's it a 1? Okay, because you can make anything a fraction by putting a 1 under. The base is 1. Good. All right, so then what would be my hypotenuse?
Square root of 2.
Square root 2. Thank you, Joseph. All right, because it's 1 squared plus 1 squared is equal to c squared, right? So 1 squared is 1 plus 1, and then we square root it. All right, so now we're going to draw our V triangle. All right, so this one says arc cosine of x, but the way I want you to read it is when is cosine x. So when is cosine x? So what is cosine? Adjacent over hypotenuse. So what's my adjacent? X. And what's my hypotenuse? 1. So what's my other side here? Square root 1 minus x squared. Okay, it's the hypotenuse squared minus the other side squared all underneath the square root. Yeah. Now that we have those triangles, it's pretty easy. So here we go. So now I have cosine of u. Well, I look at my u triangle. What's the cosine of it? Okay, 1 over square root 2 or square root 2 over 2. Which one do you want?
Square root 2 over 2.
So we're going to have square root 2 over 2. So we already rationalized it.
Yes, that's what we're supposed to do.
That's fine. All right, and then what's the cosine of my V triangle? So let's look at my V triangle. What's the cosine of it?
X.
X over 1. And then minus, now I need the sine of my U triangle. So now I'm going to look at my U triangle. And what's the sine of my U triangle? Square root 2 over 2. All right. And then what's the sine of my V triangle? So now I need to look at my V triangle. So what's the sine of it? Good. All right. So now we just need to multiply it a little bit. So now I have square root 2 times x. So I have x square root 2 over 2 minus square root 2 times square root 1 minus x squared, again, all over 2. So what did you notice here? I have a common denominator, and what else could I factor out maybe? A square root 2. So now I have a square root 2 times x minus square root 1 minus x squared all over 2. All right.
Yes, exactly.
Prove this cofunction. All right, so now we have cosine of pi over 2 minus x, which we already know is what? Sine x, right? Remember, sine of pi over 2 minus x is actually the same thing as
Cosine of x.
Okay, so you already know these cofunctions. I had you memorize them before. Now we're going to show another way why they work. All right, so which one am I using? Am I using un deux, trois, or quatre? I'm using cat. This is what I'm going to use. All right. So I'm just going to rewrite it. So now I have cosine of what's my u?
How we use, we using cat.
Cosine of x. All right. And then plus sine of pi over 2. And then sine of x. All right. So all I did was just rewrite it. Now we're going to evaluate. Well, what's cosine of pi over 2? Cosine of pi over 2. It's 0. All right. So then I have 0 times cosine x. And then plus, what is the sine of pi over 2? 1. And then I have 1 times sine x. Well, 0 times cosine is 0. 1 times sine is sine x. All right. So we just used a sum and difference formula to prove that identity. All right. All right, let's do a lengthy one now. So now we have sine of the quantity x plus pi over 4 plus sine of x minus pi over 4 is equal to -1. And I'm going to solve for x, but I'm given a domain restriction 0 to 2 pi. So how many times are we going to use our sum and difference formulas? Twice. We're going to use it twice. So on this first one, which one do we use? We use all right, so that's what we're going to do. So now I have sine of x and then cosine of pi over 4. And then plus cosine of x sine of pi over 4. And then plus, now I'm going to use this one. So which one do I use on that one? Do. All right, I use the second one. So now I have sine of x cosine of pi over 4. And then minus cosine of x sine of pi over 4 is equal to -1. All right. All right. Do you notice anything that happens before we start evaluating our trig functions? What cancels out? Okay, the second and the fourth term. The second and the fourth terms cancel, so that's nice. All right, I love it when things cancel. And what else do you notice about the first and the third term? They're the same, so how many do I have of them? I have 2 of them. So now I have 2 sine x cosine of pi over 4 is equal to -1. Well, now we need to start evaluating. So what is cosine of pi over 4? Square root 2 over 2. So now I have 2 sine x times square root 2 over 2 is equal to -1. All right. So now if I have 2 times square root 2 over 2, what cancels? The 2's cancel. And then what's going on with sine x and square root 2? What are they doing? They're being multiplied. So what should we do to start solving for x? Divide by square root 2. So now I end up having sine x is equal to -1 over square root 2. Well, that's not usually how we think of it. What should I probably do to it? I should rationalize it. So what does it rationalize to? Negative square root 2 over 2. All right. So now I need to think about my unit circle. So when does sine give me negative square root 2 over 2? Seven pi over 4 and what else? And 5 pi over 4. All right. Now, it gives me this interval 0 to 2 pi, so we're done. All right. However, if it didn't give me that interval, what would we have to add to them? Plus 2 in pi's. All right. There you go.